Hello, here is section 6.2 about roots and radicals. And it's not just going to be square roots, not just cube roots, but we're looking at other kinds of roots here. And here's the basic idea of other kinds of roots. If you have something like this, we call this the nth root of b. And what that symbol stands for, the result, a, is a number that you can do to the nth power, it's kind of the opposite of a root, and get b. So before we go into this, here's some terminology. The number n, the little symbol above the number above the square root there, that is called the index of the root of the radical. So here you have index 4, index 6. Here you don't see it, but a regular old square root is index 2 because you're trying to find a number you can raise to the power 2 to get that 16. And here we have an index 4. So that's the index. B is called the radicand, the thing inside the square root, or the nth root. The thing that you're taking the root of is the radicand. So let's do a quick example here. First, the fourth root of 81 with index 4 and radicand 81. Whatever this result is, it's going to be, we're looking for something that you can raise to the power 4 and get 81. And if you take a calculator and mess around with it, I've already done it here. I just tried 3 to the 4th power. You might just remember what it is, and that's even better to do it in your head. But if you need to use a calculator, you can. Try some stuff. Try some numbers raised to the power 4. But 3 works. 3 to the power 4 is 81, so this is 3. Here we have an index 6 and a radicand of 64. So this result, what the whole thing stands for, is a thing you can raise to the 6th power and get 64. So you can try some stuff. I don't know, maybe it's 4 to the 6th power. Oh, that's not 64, so 4 is way too big. Maybe it's 3 to the 6th power. It's still too big. What's 2 to the 6th power? That's 64, yeah. And again, you could also just do 2 times 2 times 2 times 2 6 times here if you want, instead of writing 2 to the 6th power, but it means the same thing. So that means this result is 2. Okay, the square root of 16 means, remember there's like an invisible 2 here, and just like you've been doing square roots forever, we're trying to find something we can raise to that power 2 and get 16, and you know that 4 to the power 2 works. 4 times 4 is 16, so that's 4. And this one, if you have the 4th root of 16, that means we want whatever this result is going to be something you can raise to the 4th power and get 16. And you could try some stuff with your calculator. It turns out 2 works. 2 times 2 times 2 times 2, 4 times gives you 16. So the result of the 4th root is 2. Okay, so that's just the very basics of roots other than cube roots and square roots, but it's really the same idea. Mostly for these, you just need to get practice doing things to powers. You could do it with your calculator too. It's better if you can do stuff in your head, but it takes some practice to learn what these are. Okay, so here is an exercise for you to do. Figure out which one of these is the correct rule. If you might remember it, and if you just remember it, then you don't really have anything to do here. But more importantly, you are going to forget these rules someday, and you want a way to figure out the rules. If you're in like a calculus class a year from now and you don't remember all the algebra rules, what do you do? How do you figure them out again? So here's my favorite way is pick a number for m and a number for n, and actually expand this out. See what you get. Just using the fact that something squared to the power 2 means just write x times x for that. And this whole thing to the power 3, write it multiplied by itself 3 times. And see, do you get x to the 8 or x to the 6th power? So let's pause it here, see what you get. Here's what I did. I just did x squared is x times x, and then that to the power 3 gives you x times x times x times x times x. You got 6 x's there. So that's the result of doing 2 times 3, not 2 to the power 3. 2 to the power 3 would be 8, and that's not what we got. So this one is the correct rule. Okay, now the main idea of this section is going to be about, and this section and the next section too, is going to be about exponents that are not just integers. Integer exponents, meaning whole number exponents, was the last section. But, and that kind of made sense because when you have like, I don't know, 9 to the power 3, or I don't know, let's say like 2 to the power 3, that really means 2 times 2 times 2, 3 times. But how can you do 9 times itself 1/2 of a time? It doesn't really make sense. So let's think about what that means using this rule. We want to define 9 to the 1/2 to be something that is consistent with all of the rules from 6.1. So that we can still keep using them even if we have weird numbers like 1/2 in the exponent. So let's think about what would happen if we did 9 to the 1/2, but then we took that and raised that to the power 2. If we're using this rule, what we'll get is 9 to the power 1/2 times 2. And you know that 1/2 times 2 is just 1. So that just gives you 9. So, okay, so 9 to the power 1/2, that thing in there, is something you can square. You can multiply by itself and get 9. Here's another thing you can multiply by itself and get 9. If you do 3 squared, you'll get, well, you'll just get 9. And in general, we could just say that if you do the square root of 9 and square it, square roots and squaring something always cancels out, and that's also just going to be 9. So in general, if we want all of these rules that we have to be consistent with these new kinds of exponents, we want to define 9 to the 1/2 to be the square root of 9. So that's what that is. What if we have something with like a 1/3, let's say? So we can see, what does 8 to the 1/3 mean? Well, we want 8 to the 1/3 so that all these rules are consistent, should be something you can cube and get 8. Well, something else you can cube and get 8 is the cube root of 2. So if I just wrote that with the cube root of 8 is what I meant to say. The definition of the cube root of 8 here is some number you can raise to the power 3, and you'll get 8. So that means 8 to the 1/3 should be equal to the cube root of 8. So that's that. So this is the general definition of a rational exponent. We have 1 divided by something. The denominator of the exponent, the n, becomes the index of the radical. Here is a pretty quick exercise to test your understanding of this concept, and also the stuff about negative exponents from the last one. So do it out. If you don't know how to do it, just write down that I don't know how to do it. And if you get the wrong answer, write down your wrong answer and the right answer, just like usual. And let's pause it here. Here's my answers. With a, the denominator of the exponent is 2. That becomes the index of the radical. So this is really just another way of writing the square root of 4, which is 2. When you have a negative exponent, on the other hand, from 6.1, that means it goes in the denominator of the fraction, and it becomes 1 over 4 to the power 2, which is 1/16. And here, if you got 4 to the negative 1/2, I'll just do the negative exponent part first, change it to a positive 1/2 once it's in the denominator, and then 4 to the positive 1/2 we just figured out is 2. So that's a 2 in the denominator of that one. And here, this is the square root of 4, square root of 1/4, excuse me. And you can do the square root of 1 and the square root of 4 separately. The square root of 1 is 1, and the square root of 4 is 2. And that's the end of this one. It's a little bit of a tricky concept. It takes a lot of practice to get good at this stuff, at computing these things, and remembering the difference between the negative exponents and the fraction exponents, and rules about fractions themselves. There gets to be a lot of rules here, but hopefully you develop some tools to figure out the rules in case you forget them, and most importantly, just get a lot of practice.